Hello everyone, I'm Jai from YKLP. In Chapter 6, I'm going to present a total of 4 lectures. I will introduce some basic terminologies of cladogram and morphological characters. You will learn how to interpret a cladogram when you read of it in a book or in a paper. Then, I will show some small examples of making cladograms based on morphological data. The lectures I'm going to give are not a complete survey of the types of cladograms, nor a complete summary of the cladistic methods, but will only serve as brief introduction to them. With these basic ideas, however, you will be able to do some simple analysis and will be able to read the reference more easily. Much of my lecture has been based on the 2 excellent textbooks listed here, and you can learn more by reading them carefully. And for those who want to do cladistic analysis in your research, I encourage you to read more research papers in your fields. In this lecture, I will give you a brief introduction to the terminologies used in cladogram. These include the structures of the cladogram and its interpretation. The monophyletic, paraphyletic, and polyphyletic groups are terms we frequently read of in the literature, and I'm going to explain them. What is a cladogram? A cladogram is a tree-like diagram that shows the evolutionary relationship between different organisms. Here, on the right-hand side, you can see a cladogram, for example. On the cladogram, the crossing points of lines are called nodes, and the line sections between nodes are internodes, or internal edges. The line section connecting a sampled species and the preceding node is called the leaf, or the terminal edge. And sometimes, people will add small dots to the nodes and the terminal parts of the leaves to highlight them. Basically, there are 2 types of cladograms. In a stem-based cladogram, every node represents a speciation event, and the edges stand for species, while in a node-based cladogram, the nodes represent species and the edges indicate the relationship between species, or the characters shared by descendant species. These 2 types of cladograms are interconvertible. The lines in cladograms are not necessarily straight. You can also use curved lines. The cladogram is a reconstruction of the evolutionary history, and it is dependent on the data and methods. So we should treat it as a hypothesis subjected to tests, for example, of fossil data. A cladogram is hypothetic or in the context of available data and the methods used. For example, if we do phylogenetic analysis based on different data sets of morphological characters, we may get different results. Also, if we use different analytical methods, the results may vary too. And considering the existence of species that are not included in our analysis, the topology of the cladogram and its evolutionary interpretation will also change because of the species we sampled. Such changes are even more pronounced in the paleontological perspective, when many fossil species have not been discovered and analyzed. As a result, we should regard a cladogram as a hypothesis and as changeable with data and methods we applied, and as an underestimation of ancestral species and speciation events. The cladogram is also an incomplete reconstruction of evolutionary history, and therefore an inaccurate relationship among the fossil and extant species we studied. It is very important to realize this. The most important topology in cladogram is the monophyletic group. In definition, it is a group consisting of a common ancestor and all of its descendants. It is also called a clade. When we analyze the extant species, we can regard a monophyletic group as consisting all the living taxa from their nearest common ancestor without referring to the fossil ancestors. And why do we need to erect the definition of the monophyly? First, this is to connect species derived from their nearest common ancestor. It is also to emphasize that this ancestor only belongs to this species and is not shared by any other species. Third, a monophyletic group also encompasses all the species within a closest relationship. This is to say that species within this group are more closely related to each other than the species outside this group. We should also keep in mind that a monophyletic group is hypothetic, and the addition of new taxa could change its status. For example, in the cladogram shown here, before we knew bonobo, we would have regarded chimpanzee and human as a monophyletic group. However, we later got to know that this fails to include bonobo, and it was not a monophyletic group. And from a paleontological perspective, we are not likely to be able to include all the fossil species in this clade, nor the exact ancestor species of this clade. In this sense, we would like to revise the definition of a monophyletic group as a group of species consisting of its assumed common ancestor and all its known descendants. It is important to realize that we talk about monophyletic group in the context of the data available to us. A paraphyletic group is defined as a group consisting of a common ancestor and some of its descendants. In the context of living organisms, it can be viewed as a group of species sharing the same ancestor. However, this ancestor is also shared by other species. And why do we define a paraphyletic group? This is because we want to show an incomplete monophyletic group, the ancestor of which is shared by other species, and also to remind that this group ignores important, already known taxa that are closely related to this group. A paraphyletic group should not be used as a logical taxonomic unit. Moreover, it hints that there are still species that are closely related to this group than others. A polyphyletic group is a group of species with their common ancestor not included. In the context of living organisms, we may regard it as a group of species from the same ancestor, which, however, is shared by more than one other species. The reason we define a polyphyletic group is also to remind that this is not a complete monophyletic group, but different from the paraphyletic group we mentioned just now. The polyphyletic group doesn't contain their nearest common ancestor. Species from a paraphyletic group still originated from the same ancestor, but species from a polyphyletic group do not. Polyphyletic group should not be used as a logical taxonomic unit either. Sometimes such a unit includes species with convergent, independently originated morphologies. For example, both birds and bats can fly, but their flying abilities had been invented independently. If we erect a taxonomic unit called winged vertebrata, then species in this group would not have a unique ancestor. The nearest common ancestor is shared by a number of other species. Also, the appearances of the sharks and the dolphins had evolved independently, and if we define a taxon pelagic viviparous vertebrata, then we will have a number of species that are phylogenetically close to the shark and the dolphin than to each other. It is also important to introduce the concepts of in-group and out-group. The in-group is the species we are analyzing in the purpose of resolving their phylogenetic relationship. And usually, when we do this, we choose one or a number of species outside this group for comparison. Technologically, this is to help identify the derived and primitive characters we find in the in-group and to root our cladogram. A sister group is the ideal case of outgroup. It is the outgroup most closely related to the in-group. However, we may compromise that a sister group is often hypothetic or assumed because of the great number of unknown species and fossil taxa. We can, at the most, choose the outgroup closest to the in-group according to our knowledge. To summarize, in this lecture, we have introduced cladogram and its basic structures, and we get to know that the monophyletic group is the most important topology in cladogram, and the aim of cladistic analysis is to establish monophyletic groups. Both paraphyletic and polyphyletic groups are incomplete monophyletic groups, and we need to know the ideas of in-group and out-group. To resolve the internal relations of the in-group, we usually need an out-group, and ideally, the sister group. But in phylogeny, the sister group is also mentioned in the context of the two most closely related lineages. Okay, that's all. In the next lecture, I will introduce to you the morphological characters based on which we establish a cladogram and the method we code these characters. Thank you.